Okay, I want to try to go through our packet where we are thus far. So on page A1, we started with the graphs and, oh, I'll lay my packet down. But we graphed cosine, sine, and tangent. If you were not here and you do not have that, you need to get these graphs. We talked about the domain and the range of each of those. So we did sine, cosine, and tangent. I know that this was tangent here, and this one was blank. Then we talked about some graphing practice. We talked about shifts. This is something that you can put in Desmos.com. You want to answer these questions. You were to have done this, I think it was like 2 weeks ago. More questions about the shifts. How does this affect the graph? So this is graphing all the way through B, looks like B4. Okay. Then we started on inverse trig functions. We talked about the notation for inverse trig is a -1, kind of like an exponent, or the word arc sign. We took notes on all of this. Again, if you were not here, you need to get those notes from someone in class. We talked about the inverse cosine. This was the day that we were in our lab room, and we took notes on all that. And then we talked about the inverse trig. Again, if you do not have these notes, you need to get them from someone in the class. We did this worksheet. We had a quiz. You either had the even or the odd from this paper on your quiz. And so the next topic is word problems. Now, we did the law of cosine in our flip book, and we did some problems. You have not done these word problems yet, but I'm getting ready to look at that with you. So we'll skip over F1 and F2, as well as F3 and F4. Notice the answers are attached. Okay, we took notes on the law of sines. I know we did number 1. I think we did number 2 as well. Law of sines is used for angle, angle, side, angle, and side, angle. And then we took notes on the law of cosines, which is used for side, angle, side, and side. What I want to talk to you, okay, and these word problems have been done. These are posted on a Collaborate video. So make sure you watch that Collaborate video so you can get those word problems. But what I want to talk to you today is about, let's see, this is page I. It is the area of a triangle. Now, we know the area formula for a right triangle, okay? So if it's a right triangle, I'm not great at writing with this pen, but if it is a right triangle, we know the area formula is 1/2 the base times the height. But what if it's not a right triangle? This area of a triangle, this formula right here, works for any triangle. It does not have to be a right triangle. Okay, so you've got two options, and the first one is when you have side, side, side. You only use Heron's formula if you have the three sides. Your sides are A, B, and C. Okay, so these are your sides. You would have all three of them. And you have to, it's not an average. Okay, notice we're dividing by 2. This is not an average, and that's a mistake that a lot of people make. But you add up the three sides and you divide by 2. Very important there. You're dividing by 2, not 3. It's not an average. And this is the formula. S, which is this special number you get over here, you take S and then S minus side 1, and then S minus side 2, and then S minus side 3. The order of the sides does not matter. And that's it. So let's look at the first one. This is on your worksheet. A is 15, B is 12, and C is 18. Find the area. So this is a side, side, side situation. So we're going to add up the three sides, 15 plus 12 plus 18, and then we're going to divide that by 2. I think it's 45, but honestly, I'm having a rough day today with some personal things. Yeah, 45. So we get 45 divided by 2. And that's not going to go in there evenly because 45 is odd. And so we're going to get 22.5 as our S. This number right here, this is S. This is not the answer to your problem, but it's going to be S in your formula up here. So what you do is you take a big radical. Okay, you start with just plain S. So plain S is 22.5. Then you do S minus one of the sides. Honestly, the order doesn't matter. So 22.5 minus 15. Then you do S minus the next side, so minus 12. Then you do 22.5 minus 18. And you're going to put all this in your calculator. You can simplify it if you want to, but if you use your parentheses correctly, you can just put all of this. Now notice it's under the radicals. You have to have a big radical outside. And when you finish that, you put it in your calculator. The area is 89.29. So this is the area of that triangle that has those three sides. This is area. The area is equal to 89.29. Okay. I'm going to let you all do the next one, but I am going to tell you the answer so you can make sure that you're on the right track. So when you work this problem out, practice it for yourself, but the area should turn out to be 13.42. This is the area for this example, but make sure you practice it yourself. You know I will be collecting your notes. All right, so that is the area formula if you have the three sides, but we don't always have the three sides. So we have another formula called the sine formula, and you use the sine formula if you have the side, the angle, and the side. Again, this works for any triangle, okay? Any triangle that you have a side, angle, side. It does not have to be a right triangle. One thing I want to make sure you're doing is that you're drawing your picture. So okay, one angle is 131, so that's an obtuse angle, so I'm going to make this look like that. All right, alpha is 100, oh, that's a 31, 131 degrees. There's alpha. B, okay, let's just pretend like this is angle B, this is angle A, and this is angle C. So side B, that means it would be opposite angle, yes, opposite angle B is here, and C is opposite angle C, so 25 would be here. Now, I didn't draw my picture great, but we have a side, and then we have an angle, and then we have a side. If you have side, angle, side, you're going to use one of these area formulas. Now, to be honest, they're all the same, so don't get bogged down in memorizing a bunch of formulas. Okay, we're going to take half of the sides, which are 25 and 10, and then we're going to take the sine of the angle in between, which is 131 degrees. Make sure you are in degree mode because this is a degree. So we'll put this in our calculator. Half of 25 times 10 times the sine of 131. Oh, I didn't have mine in the right mode. Sorry, hold on. Okay, the answer is, we want to round correctly, so the area of this triangle is 94.34. This is the answer to this problem, 94.34. Now, actually, the next one's a little bit easier because I gave you the picture. This is your side, this is your angle, and this is your side. Once again, I'm not going to work this one out, but I'm going to tell you it's a larger number. The area is 14,469.85. So this is the area for this triangle. Make sure that you're practicing these on your own. Okay? Now, let's kind of skip over some of the other pages. I want you to use the law of sines and Heron's formula to complete this worksheet. It's not that hard, okay? So if you look here, you have side, side, side. This one is side, 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 and once again. So all of these are going to be Heron's formula. Now, if you look at the other ones, you start seeing that we have side, angle, side, side, angle, side. So this is pretty repetitive, but you're going to practice the formula. This is not difficult, so it's a good thing for me to have to make a video on because it's really not that hard. Side, angle, side. This one is side, angle, angle. Oh, and this one is angle, angle, side. Now, let's look at these two down here, 11 and 12. I don't even think I realized that they were on the worksheet. But what you'll have to do here is you'll have to use the law of sines first. So let me show you what this is going to look like. Okay, so 39 goes to, let's call this B, and 111 goes to, we'll call this A. So remember the law of sines. You've got the sine of 111 over 6 equals the sine of 39 over where's the third sine of 39 go to? Over B. Okay, and we'll use that. That'll give us side B, and then it looks like if we get this angle right here, actually, sorry, I can do that easier. Let's erase this. Let me see if I can erase this. Sorry, let me see if I can erase that. Let me just see if I can start over on this problem. Scratch, scratch, scratch. Rewind my video. Okay, let me start over on that one. Okay, well, let me see if I can get a pen. There we go. Okay, we know that there are 180 degrees in a triangle. So if we subtract the 111 degree angle that we have and the 39 degree angle that we have, we can get angle X. So 180 minus 111 minus 39 leaves us with 30 degrees. 30 degrees is right here, okay? So we have angle, side, angle, or we have, what is this, side, angle, side. No, that's an angle too. So we have to figure out one of the sides, kind of what I was talking about earlier, but we have the angles. So we want to get this side right here. This is the side that we're interested in. So we will have, why do I want that side? I started out with the other side, but I realized I need a side, I need an angle, and then I need the side that is opposite it. So since this is 30 degrees and this is opposite 6, we'll say the sine of 111 is to 6 as the sine of 30 is to X. Let me pause this real quick. Hold on. Okay, I'm sorry, I had a phone call, and while I had a phone call, I just went ahead and solved for this side. Okay, so we need side, angle, side in order to use the law of sines. And so what I did down here is I used the, well, I should say for the area formula, I used the law of sines to get this side. This side is now 3.21. And so now, let's change pens. I have the side that I need in 6, I have the angle that I need in 39, and I have the side that I need in 321. So what I do is I do 1/2, because we're going to use the law of sines for the area of a triangle. I take one of the sides, which is 6, the other side, which is 3.21, and then the sine of the angle in between them, which is 39, okay? And you're going to have to do something very similar to that for number 12. So side angle, what we really need is this side right here, and you're going to have to use the law of sines to get that, okay? So you need to use the law of sines first. I know that's sloppy. Then find the area, okay? All right, I want to look at a couple word problems. Oh, I'm about out of room, or I'm about out of video. I think I'll stop. I think I'll stop the video. I only have like 50 more seconds. And so this video covers the area of the law of sines. Now, let me refresh your memory. Law of sines is exclusively used for side, angle, side. Heron's formula is used for side, side, side. All right, thanks.